Okay, so first couple examples, we're going to use tables like we've been doing in the past for finding our limits. And then after that, we're going to actually move over and use Excel to help us find the limits because it's a little easier to negotiate some of these larger tables of data and all the decimal points, and we don't have to keep doing that in our calculator as much. All right, so here what we want to do is we have f of x equals 2 to the x. We have x equals 2 is what we're going to look at, and we want to estimate to the nearest tenth. And we're supposed to numerically estimate the slope of the line tangent to the graph of the function f at the given input value. Show the numerical estimation table with at least 4 estimates. So, we have at least 4 estimates here. And so what we're going to do is we're going to have from the left this way, and we're also going to have from the right this way. And 2 is where we're estimating at. So we're going to go 2 from the left and 2 from the right and do that. I'm going to have a middle function. I'm going to have f of x, and then we're going to have that slope of the secant. Now remember, the slope of the secant is f of, in this case, it's going to be 2 minus f of x, which is going to be this middle column, all over 2 minus, and then we'll call it whatever x is, okay? That's going to be that column. And it's going to work for both of the slope of the secant lines. All right, so what do we have? Well, let's write our numbers in here first. So that's going to be 1.9, then we have 1.99, 1.999, 1.99994, okay? And then we have 1.12345 and 1.12345 6. Okay, so I think that should be good. And now what we're going to do is we're just going to take 2 to that power. Okay, so if we just plug in our calculator, and I'm not going to show you me plugging each one of these in, 2 to the 1.9 is equal to 3.73213196. Okay, so let's write this out. So let's use 3.732132. We'll just go out to that far. Okay, now if we plug in that one, then we're going to get, we show 3.972370, and here we get 3.997228. Here we get 3.999723, and here we get 4 nines, 3.999972. And then we get the 3.12345 7. Okay. And we could keep doing this. And what happens is we get that 9, and then we get another 9, and then everything pushes down and keeps pushing down. And so that's how we're getting that. Now what we're going to do is we're going to take f of 2. Well, if we plug in 2 here, that's 4. So basically we're going to take 4 minus our f of x over, and then we'll have 2 minus our, in this case, our x, whatever that is, this thing. So we're taking, that's our f of x. This is going to be our x, and we know our 4 and 2. Okay, so again, you just plug that into your calculator, and so you just do, 4 minus, and then 3.732132, and then parenthesis, and then divide by, and then we'll have 2 minus 1.9 in parenthesis, and in this case we get 2.67868. Okay, but let's see, what do we have? We have to go to the 10th. So if we're at the 10th, say we have one, I'm just going to write some numbers. 1, 2, 3, 4, 5, 6. If we're going to the 10th, we only need to go out 2 spaces beyond that, remember, based on our long time ago in chapter 1. And so that's, we just have to go out basically 3 decimal places. And so here, 3 decimal places would be 2.679. Now, if we plug in all of this, then we're going to get 2.763, and then 2.772, 2.773, and then it keeps going 2.773, and then 2.773. Okay, so what do we get? Well, we get the limit of the slopes. I'll just call it the slopes, as x goes to 2 from the left is approximately equal to, now it's rounded to the nearest tenth. Well, if we round that to the nearest tenth, that goes up and it's approximately 2.8. Okay. Now, the same thing goes over here, except instead of going from the left side, we're going from the right side. So that'll be 2.1, 2.01, 2.001, 2.0001, 2.12341, 2.12345, okay? Now we do the same thing there. We plug in, and 2 to the 2.1, is 4.287093.850. But what are we going to write? We're just going to write part of that there. So we'll just write 4.28709994. Okay. And then if we keep doing that, we get 4.027822. And then we get 4.002773. And then 4.12327. Oops, let's write it all on the same line here. 4.123 and then 277. And then we have 4.12342 and then we have 4.12345 and 3. Okay. Now, when we plug that in, we're going to take, again, similar to what we did here, f of 2. Well, that's going to be the 2 minus, or 4 minus, rather, f of x over 2 minus, or x. And again, we're just using this f of x and these x values. And so when we plug that in, we're going to get a number that's pretty long. So let's try the first one. We'll get 4 minus 4.2870. 94 divided by our 2 minus 1.9, or 2.1, sorry, we're on 2.1 now, 2.1. And so we get the 2.87094. But again, we only have to go out to 3 decimal places, so we're going to get 2.871. Okay, and this one becomes 2.782, and then 2.774, 2.773, 2.773, 2.773, and here again our limit of the slopes as x goes to now 2 from the right, that's approximately to 1 decimal place 2.8. Okay, now what we're supposed to show is that derivative, the f prime. So f prime at 2 is equal to, well, guess what? These two are equal. Since they're equal, f prime of 2 is equal to the 2.8 as well. And maybe we want to say it's approximately equal to, because that's really what it is. And so this, we could say this and put it in between here, because that's what we're doing. We're taking the limit of this whole thing here, but we're just going to write basically our final value, because we have all these things we've calculated. So we'll just write our final value. Okay. All right, so let's do another one here. So with this one, what we're going to do is we're going to use our calculator, and we're going to take 5 times ln of 5, and that's going to be, what this is. So we're going to have f of 5 minus f of x over 5 minus x. And so we're going to do all those things. So what's from the left side here? Well, from the left side, it's going to be 4.9. Then we have 4.99, 4.999, 4.1234, 4.12345, 4.12345, 6. Okay. Now we type that into our calculator, so we'll have 5 times the ln of 4.9, and that's going to give us see here, 7.946176026. And what are we going to write that as? We're just going to say that's 7.9461760. And then we do the same thing for 4.99, and we get 8.037180. And then we get 8.046189, and then we get 8.047090, and then we get 8.047180, and where'd the top of the 8 go? And then we get 8.047189. Okay. Now we're going to plug all that stuff into here. So 5 times ln of 5 is equal to 8.047189.562. And then we're going to subtract off of that the 7.946 176, and then we're going to divide that by the point 1. So it looks like we get 1.0101356622, but now we want to the nearest hundredth. So it's 0, 1, 2, 3, 4, 5, 6. So the hundredth is here. So we just have to go to 4 decimal places. So that would give us 1.0101, and this one going to be 1.0010. Then we're going to have 1.0001. Then we're going to have 1.0000, and that's going to be what it gets the rest of these here. All right, so that gives us the limit of the slopes as x approaches 5 from the left is approximately equal to 1.00. Now it says to the hundredth, so we have to remember to go ahead and put those 2 decimal places here. All right, what about over here on the right? Well, all we have to do is we have to write in our values. So we're going to have like our 5.1, 5.01, 5.001, 5.1231, 5.12341, 5.12345. Now we just take and say 5 times ln of 5.1, and we get 8.146202699. And so I'm going to do this as 8.146203, and then I'll have 8.057.180, and then 8.048189, and then we have 8.047290, and 8.047200, and 8.047191. All right. Now we have to take that again, what we found for the ln of 5, the 8.0471895562 minus the 8.146203 divided by the 0.01, or 0.1 rather, on this first one. And so when we do that, again, we have to go out to 4 decimal places. And so that's going to be a roughly 0.9901. That's going to be 0.9990. 0.9999, and then we're going to get to the 1.000, 1.0000, 1.00004. Okay. And so same thing happens here. The limit of our slopes is going to be approximately 1.00, as this case x goes to 5 from the right. Okay. Now, what does that tell us? F prime of 5 is approximately 1.00. And we found that once again by doing our limits here, okay? All right, so again, this is going to be the long way. This will be, you have to do one like this on the test probably. But then from now on, we're going to look at doing them via Excel.